All right. So if I want to rotate A around 4, 5, we put those axes in and rename 4, 5 as 0, 0, right? Okay. Now, if I rename 4, 5 as 0, 0, then this and every other point in the plane should get named off of this 0, 0. So I'm going to count over as -3, -2 to rename that point there. Correct? Okay. Um, so the whole idea then is what we've just done is really got rid of those other axes. And now we're going to rotate around this origin, this being 0, 0. Does that make sense, everybody? Okay, so when we rotate, and again, I'm just going to use the 90-degree rule for rotation. So if I rotate 90 degrees, remember that's if A comma B is your pre-image, then the opposite of B comma A becomes your image. So this right here, this is our AB, -3, -2. So it's going to turn into, so this turns into, you flip-flop them, so -2, -3. But now you add this extra negative into that x coordinate, right? So this is -2, and if I add another negative in there, what's it become? +2. Okay? So now I'm going to go from 0, 0, and I'm going to go plot 2, comma, -3. So I go over 2, and then down 3. And that point right there should be A prime. Okay? Now, if you remember what we did earlier, I took out the traditional normal axes, right? So these really aren't there. It's these that are there. So how do I name A prime off of those? 6, 2. Okay? And that's then how we rotate this point. Okay, if I ask GeoGebra to rotate A around R, let's do 90 degrees here. If I rotate it 90 degrees, come on, 90, you see that it is indeed at 6, 2. Okay. Now, we walked through some stuff yesterday, like towards the end, that allowed us to maybe quicken that process. Okay, because every time I rotate a point, that's what I'm going to have to go through. And we talked at the end of class yesterday, well, what if the point is a really, really ugly set of ordered pairs or coordinates that are really, really big, or maybe even really, really small, or maybe irrational, and we can't necessarily count real nice. Or even they're just fractions. It's a pain in the butt when they're fractions. We should be able to go through an algebraic process that will generate this rotation for us. And here's the idea, or here's the process. And I'm going to get rid of the grid line here so we can write stuff a little bit easier. When I renamed this point as -3, -2, how could I have gotten that through the use of 4, 5 and 1, 3? How can I get -3, -2 through the use of those two ordered pairs? I can subtract them, right? Okay. If I take the x value of A and subtract from it the x value of R, comma, the y value of A minus the y value of R, that should produce this point that I need to apply my rule to, right? Okay. 1 minus 4 gives me -3. 3 minus 5 gives me -2, right? Okay. Let's see if that works for any other point. Once I developed that rule, I want to make sure that rule wasn't just a coincidence for that ordered pair. So let's move this point here to 3, 3. Okay. If that's 3, 3, you would have called it from this point -1, -2, right? Well, can I get that same -1, -2 by taking 3 minus 4 and then 3 minus 5? Yeah. And it works, guys, regardless of where my rotation point is. If that's my rotation point, counting over gives me 1, 2, 3, 4, and then down 1, right? So this point should be -4, -1 off of this rotation point. But how can I find that? I can take the x value of A minus the x value of R, gives me -4, and then 3 minus 4 gives me -1. So this is a formula, so a small formula to allow us to essentially rename all of our ordered pairs off of those axes instead of those axes. Okay. Now, this is my notation, so I'm not saying that you would look in a textbook and see this, like x sub A. And I'm just using A because that's what I called that point there. Sometimes I'll use like a P for just point. But then the next thing we did is that we rotated that point. Okay, so you apply your rotation rule to that point. Okay, and then you plot that point off of your rotation point. Okay, and what that's going to do, so looking at this one, we have, so what do we call this? So it's -4, -1. We then apply our rule, so that's going to become, when we apply our rule of a 90-degree rotation, it's going to make it +1, -4. So I go +1 here, and then down -4. You see that's putting my point right there, correct? Okay. But that would have been, we're calling that 1, -4. GeoGebra is calling it 8-0 because GeoGebra is labeling it off of these axes here, right? Well, how can I get from the use of that there and that there, how can I create this final answer question or solution? I can add those, okay? So thinking about what this does. This is taking the x value of essentially A prime. A prime would have been, let's call this one here A prime. Okay, it's taking the x value of A prime and adding to it the x value of your rotation. And then it's taking the y value of A prime and adding to it the y value of your rotation. And if I do that, if this is A prime, 1 plus 7 gives me 8. And then -4 plus 4 gives me 0. Does that make sense, everyone? Okay. So I want to do this with you in regards to an entire shape instead of just a point. Okay. Because if I am just doing one point, guys, it doesn't make a whole lot of sense to maybe use those formulas. Okay. But if I'm doing a point that maybe is like this, like A is located at maybe like 2 pi comma square root of 3 divided by 2, something really ugly, which is going to be this point here. Now, if I was leaving it in the notation that I used to write it, I want to rotate it, I would probably want to use the formulas because it's going to just be really difficult to put that in, check my grid, and now count over that many units. Does that make sense? Because that's not at an intersection of grid points or grid lines. So using the formulas would be the best thing there. It's kind of like slope. If I wanted to find the slope between, that point there and that point there, that's pretty easy. I count up 1, 2, 3, and over 2, right? But if I wanted to find the slope between those 2 points, can I count up real easily? No, I don't know exactly how low D is. I don't know exactly how high E is. I don't know that vertical distance real well. And for the same reason, I don't know that horizontal distance real well. So I would use the formula because that is always going to get me the right answer. So that's maybe when I would have 1 point and I'd rotate 1 point and when I would use these formulas. Other times that I would use these formulas is if I've got multiple points to rotate, okay? So let's do, I got a series of points here. Find out where I put them.